Meanwhile, for perpendicular lines, we are looking for those that intersect at a right angle, or, well, 4 of them forming something like a cross shape. Where, to be clear, much like with even and odd functions, parallel and perpendicular lines are worth studying for their being special, but they are kind of special. Most lines do not intersect at right angles and still do intersect somehow. Anyway, when we're talking about perpendicular lines, it's worth again seeing that etymology where, in particular, the idea of these things, the idea of that wording comes from Latin, comes from the word perpendiculum, referring to a tool called a plummet or plumb line, where plummets consist of a weight hung directly from a string off of a beam to notate a vertical drop. Although you're probably more familiar with the word plummet in the verb form that it influenced.
I hope that's not a hostage.
In any case, for these, we have similar ideas to what we talked about with parallel lines, where we say that the product of the slopes of 2 non-vertical lines are -1, that is, their slopes are negative reciprocals, if and only if they are perpendicular, That is to say, the product of the lines being -1 is the same as the lines being perpendicular. And on the other hand, a vertical line is always perpendicular to a horizontal line. Where, for some more context here, the idea of perpendicularity, I'm not sure what the right form is for that, but that idea can be extended into more general ideas, as you might see with linear algebra and pre-calculus, depending on how far you go and what you learn, in terms of things called normal and orthogonal and orthonormal, planes, lines, what have you. That's, again, well beyond us, but it's worth understanding here that the idea of perpendicular lines can extend quite far beyond where they will intersect, as it were. But for us, let's get another quick example. So for this, we want to find the slope of any line perpendicular to the line y equals -1/2 x plus 5, where, as we said, the defining property of perpendicular lines is that they have slopes which are negative reciprocals. That is, you flip it over, throw in a negative sign. So because in that case, for this here, we have a slope of -1/2, the slope we want for our perpendicular line will be m equals +2. That's all there is to it. Just flip and flip, I guess would be the way to say it. Anyway, those are our main properties here. What we're going to finish this section with is talking about something that we saw a little bit earlier on. We're going to talk more about the idea of slope as a representation of a rate of change.